Okay, as always, we're starting with extracting primitives so we can align our object to the coordinate system. Basically, this time I'm going to fit cylinder to this surface. It's another one primitive. I'm going to fit plane here. That will be constrained perpendicular to cylinder. That's third reference. I'm going to use this cutout. So basically, I will create sketch that will be used as a third axis. We have like two boundaries of this cutout, and I'm going just to make middle line of two. And just close sketch. Further to aligning. Okay. Perfect right now. Now we can close. Now we can hide all of these features and basically start our modeling part. I'll start with sketch for a rolled surface. I'll just find some region where is better scan data. And let's go with this. Writing some lines. But if someone is not familiar yet with this, you can hold your shift button and drag over these points, and software automatically fits lines here or arcs. It depends what kind of shape is sliced. Later, if you're holding Control and hover over two end of lines, it will just connect them. Don't need. Go to the bottom. Connect these. Here. It should be horizontal. Okay, it looks good for revolving. Step done. So we have this revolved surface, not surface, but solid. Probably we can add our fillet here. instantly. Oh. And hide our solid. And we can start with unrolling our mesh. So basically, for unrolling mesh, you need cylinder. Select our mesh. Click unroll, and it asks you to pick a cylinder. So pick our cylinder, and this plane which appears here is like starting point of unrolled mesh where you would like it to be. Typically, the best way to use it in some like more flat surfaces, for example, is this part here. So just drag it to this position approximately. Click on preview, and you have unrolled mesh. So if you assume it's okay, click OK. And now we can hide all of this and continue with our unrolled mesh. So this mesh is unrolled like on top plane. We can go to sketch. Too much of bad scan data. This looks pretty good, I guess. And from here, as typically, we start to create our sketch. So fitting lines. Here also it's more or less straight. Of course, I'm not going too deep into these like precise numbers, so we're just showcasing how can you achieve this result. And that's why I'm not going to change any dimensions there. I'll leave it just as it is, just to speed up the process. For this part, probably we can just use a critical feature as fit curve. Drag all the points from one side to another side and click fit curve. So it automatically fits curve and tolerance within 0.1 millimeter. Well, actually, maybe let's replace this one also with the same approach. Okay, so we have our two curves. Click OK. And at this point, we need to create another sketch to capture this surface in like the deepest part of this groove. Well, again, create. As we see, and in deeper part, it's quite different. So at this point, we have to consider if this part is worn out or it's designed to be like that. So most likely it's not, because like it's a guide for some pin, and definitely it shouldn't be different from like from surface that is close to outside and surface that is deeper in this groove. So at this point, I will assume that this part is worn out, and I'm going just to convert our previous sketch. Okay. And we have like two identical sketches. One is representing like deeper part, one is representing the part of surface that is closer to outer cylindrical surface. And now we are just going to our history tree, click on one sketch, right click, click on roll sketch. So what it does, it rolls this sketch back in 3D according to this roll cage that was created based on the cylinder we fitted previously. Blah blah blah. I guess Kote could tell something more scientific about this. I'm not that deep in this process.
Well,
he is like creator of this.
Yes, let me try to explain. So if you think about the cylinder, it's unrolls, it's the cylinder. We can think about the cylinder also as a xy coordinate. So y coordinate is along the cylinder in this direction. This frame, if you go to open the frame on the left side in the feature tree, this is defined just from the cylinder, and this is what kind of maps the 2D space into the cylindrical space. So that's why when you do 2D sketches, you need to do this in the XY, and the length of the sketch needs to be the circumference of the cylinder, how it's unrolled. What else we can say? In the recent version, we introduced actually now the freedom not only to roll back the 2D sketch, but also to put back a 3D sketch. So you can freely model something in 3D space. There are some applications, and then you can roll back again. Now, in this example, which Victor shows, you have two options. One is like he made the big cylinder, but you can also use the inner cylinder. But depending on what cylinder you're using, you can experiment yourself. The mesh may look different, and this is again from a mathematical point of view, but the rollback will behave in the same way. So if you have any questions about this rolling and rolling algorithm, please feel free to ask right now before he continues. But I hope it's clear. You can just play a little bit and find out yourself about this.
Yeah, this is actually super useful tool. Probably if we will have some time, I'll show you one different project where I tried to use it with like 3D sketches, like something that people typically don't consider to be useful. And at this point, when we have these rolled sketches, we see that we have break in them. What we're going, come back, edit. Basically, here you have two options. You can just pull them. I'll probably add blend curve. I guess if you are adding blend curve, you have to join them. Well, and if you need to join them, just select two of these curves. Selecting one, selecting another one. And right-click, join curves, and just hotkey J. Okay, let's prepare another sketch. Here we can just try to drag it. Yep. So blend curve is the way. Select both of them, tap J. Okay, so now we're ready to go. Basically, we have two completely closed loops, actually 4 right now. And what we're doing, we're going to surfacing left. Select one, select another. So actually, we can later extend these surfaces, but it's way faster and easier to do it here. So you're just setting expand, like for example, 5 millimeters. And we can do more just in case. Okay, so coming back, switching back our sketches, repeating left function on our top surface of this groove, expand by 7. Okay. Well, now we have these two surfaces that are representing our groove. Looks pretty nice. Trim anything yet because we need this inner cylinder. In order to get one, I guess I will just create another revolved sketch. But yeah, actually, here you can see that this surface is way from being flat, so it means it's worn out pretty much. And I assume that when this part was manufactured, like this not conical, but cylindrical surface vertical was actually coming from here to here. And this whole part is just worn out part of this industrial part, whatever is that. So, but okay, we'll assume this is our surface that we need. And I'll just extend this line. Something like this. Click on revolve. Okay, so we have a third surface. 2 lefts, cylindrical surface, and our solid. At this point, we can start our trimming. Select all of them, click on trim. Start trimming away all the unnecessary parts of it. At this point, it looks like everything is fine, but it's not fine because you see that here we have notification. It's still like multiple surfaces. So it means we have still left some surfaces that we have to trim away to get it as a solid. What we can do, we can start to hide one by one all these parts. And yes, here we have. So basically, we have to delete this part, as long as this one and this one. And now we see this notification appeared. It's like solid body. And now just click OK. Voila. And we're pretty close to this. Can take a look and compare. Yeah, as I said, as I used like just copied outer sketch to the inside. That's why we are away here from our tolerance. Same as here. Basically, these surfaces are most likely worn out. And let's say I kind of repaired this part. And from now, we can continue with our features that we need to create here. This cut out for some kind of pin or something. cool feature we have for fitting primitives. It's called the float. So basically, you can select all these parts. That reminds you, here should be slot. Click on slot, and we have slot. Perfect. Extrude. Again, we have nice tool as snapping. Just hover over, find. Well, as this is quite nice and clean mesh, it's not a big deal to find perfect spot. Sometimes if you will have some more grainy or noisy meshes, you will be able to see how the color map is changing here while you're moving this point around. And I just pull it up, bring back our solid, and here choose cut. Perfect. And we choose as next. Inside we don't have anything. So, okay, let's create these mounting holes or whatever is that. Again, sketched based on top plane. Let's find out where we have some nice section of mesh for a cross-section sketch. I guess this one is good enough. And again, you can just hold your shift, drag around. It fits circle automatically. Drag around here. I don't remember this was like going completely through or not really. So here you can see that actually this I will create a separate feature because I remember there was way better positions for taking like cross section of this hole. Yeah, here on the bottom it's really smooth. And bring back our solid. Cut. Okay, perfect. Adding solid. Again, 2D sketch. Basically repeating the same operations again and again and again until you reach your all goals. Perfect. And yeah, we can still have this cut out here. That part isn't quite nicely scanned, but as it's just demonstration, we will assume it's fine for what it is. Let's say it's curved. And just extend beyond the limits of your solid. This time we'll do just extrude. So we have again trimming surface. Bring back your solid. Trim. Cut this, cut this. Okay. Well, so we have here these like indents. So let's create another sketch. And here, this time I will ignore scan data. Yeah. And I will bring back our solid. Here I have like center point of circle that was used to cut these holes previously. I'm just going to use this as a reference to snap to it. Now, then hide our solid. This way, I'm just going to adjust it. So in this case, it's like a bit moved away from overall scan data. Well, again, we have to consider it's like what kind of part it is, how perfect it was previously. But logically, if you have like this indent here for fitting your like bolt head or something, so it should be concentric with the hole itself. So that's why I'm going to use center point of this circle. I'm going to do same on this side. Snap to center point. There's okay. Again, snapping. Our bottom surface, drag to this face. Looks fine. Bring back solid. Actually, this time we won't use this cut feature, but we'll just create two solids. So now we can select our main solid and select feature cut from selected solid. So click on this and select solids you want to use as a cutters point, and it's done. Just another feature how to achieve the same result. What else do we have here that we haven't created yet? So yeah, we have these two holes, or I don't know how to call it, from the radial side of our cylinder. Actually, how can we create this? Does anyone have some ideas? Would be interesting to hear, as we have plenty of time still. Balancing.
No, keep teaching.
Okay. Yeah, so how we can create this? Let's take a 2D sketch, actually. Actually, Costa will have to implement one more function for creating planes after this webinar. This time I will just eyeball it. Put it in the center. Create. Okay. So we have these two cutouts, and as they are coming out from like cylindrical surface, most likely they are coincident with axis that comes from center of cylinder. Basically, just to use it. Okay, going to use this line as a revolution axis for our revolved surface, like this. Create. This line. And revolve. This time I'm going to leave it as a solid again, because we have two of them. So at this point, let's do the circular pattern of this. Circular pattern axis, z-axis. We have two instances on 360 degrees. Let's just decrease it to 45, for example. Oh, we're close. Let's say it's 60. $62 degrees. No, it's too much. Of course, you can do always the same. Create another axis for revolution, revolution feature, and create another there. But this time, it's actually a cool way to showcase how can you use circular pattern and like not your regular ways, how it's typically assumed to be used. So we have these two. Let's add this sketch, bring back our main solid, and again use cut from selected solid feature. Select both of them. And here we are. Basically, we still have some chamfers here and there. Chamfer. Option is on. This tolerance option is what I really like in QUICKSURFACE. It's really handy. Create and stay here. Also, I had chamfer. Really nice. Just drag and there you go. Create and stay. Here we still have one feature that we haven't reverse engineered in this part, so we have the same indent on the bottom side.
But you can leave this for the home exercise. So you can leave this for home exercise for the people because you showed a lot on this specifically.
Of course. If no one is asking questions, and we still have some time, so why not?
Victor, one question.
Yeah.
Can you also select multiple geometries and add the chamfer? Because
Yes,
you did one by one? Or, yeah, maybe to
yes,
apply one dimension to all the geometries.
Yes, I did that on these holes, and of course, you can. For example, here I am selecting one side and another side. Just the thing why I wasn't doing that for like different features on this part, because I don't know if they are same. They might look same, but as you saw, in some places it was 1.25, in some places it looked like 1.4 millimeters, so only reason for that. So for example, here I know that it's for sure the same chamfer here all around. I'm selecting two of these edges and then adding chamfer. And then so here it's like 2.5. Do we have some more questions? Maybe someone wants to ask something or confused about something or have some ideas.
It's not a question, but I'm impressed about the functionality and how fast you could reconstruct this scan data to cut data. So,
Well,
yes.
thank you, Sven, for saying this. I'm very happy to hear. But the reality is, some people expect this to be even faster. Just they say,
yes, until they need to do it by their own.
I mean, the thing is that the mechanical engineers, they need to have control, and the reason for reconstructing one by one is to have this parametric feature tree, because this is what you actually need at the end. That's why here you have this fillet. You can come back later and tweak and change it to 2.7 or whatever. So this is what the design intent is. Yes.
Yeah, another thing, probably some persons might not know this. If you have like planar surface, you can use this planar surface as a starting point for your 2D sketches. Same as cylindrical parts of your revolves can be used as a starting point for 2D sketches for revolved parts. Just to mention some more functionality. Okay, let's again ignore scan data. Let's create these, and then same way as previously. I think it was 20 millimeters. 20. Say, oh, here it looks like more.
I have a question.
Yes.
When you unroll the model, you make a 2D sketch for the geometry. And after unrolling, the 2D sketch is a 3D sketch.
Yes.
Okay.
Yes, it becomes a 3D curve. It's a 3D.
Okay.
Yes, actually, if you stay on the line when you finish, because we're speaking about roll-unroll, Victor, I would like to share another example, which is very quickly we can do, but
first,
to complete this first. And,
this is just last click. We are done.
Okay, great.
So now you can show what you wanted to show. At this point, I guess I am.
Yes, thank you, Victor. I'll come back to you. It's just a similar example about if you stop sharing your screen. And would like to continue about the power of roll-unroll. So first of all, this part, because we are recording, how you can access this part is you go to help, you go to video tutorials. They will take you here, step-by-step exercise, and you will find this nice little piece. So let's go back and why I'm showing you this and what is really interesting about the engineering thinking, how they build everything. So this is super complex shape here. And let's do quickly unroll. I will just go and make a cylinder. This cylinder is exactly on the z-axis. We'll create it, if you remember. Now I'm going to unroll using this cylinder. Again, you can adjust where it should start, not in the middle of one blade, but just probably somewhere here, and I can preview. The magic here is that what you see is that actually this is super flat. You know, it's an extrusion. In the reality, it's so bended and complex here and stuff, but when you flatten it, this unroll becomes a, you see, it's just an extrusion, just vertical extrusion. So let's quickly, I mean, in this case, you can make much more accurate redesign. Again, you can just go and take this cross-section here. I can create this sketch just only on this one. But now instead of just drawing, I can just fit an arc here and fit another arc here very accurately, because this is what we always think about design intent. So, and now if I just press OK, I have this one single 2D sketch. We'll use the opportunity to show, because you have two, like Victor showed for later for this lofting, we need to make another one here on top. Now, in this case, I'm going to use what is called project the others. I can just pick the others from the other sketches. The reason is that in this case, I don't want to follow the shape, but I want this to be perfectly on top of each other. And again, back to your question, if I just go roll back this this sketch back to the 3D, you see now that they nicely they are positioned into the onto this 3D object. And this is to answer your question, is no longer an arc; it's more complex shape, and this is a 3D sketch. Of course, you can edit, and here you can add the blend curve.
Oh, okay, cool.
Sorry, I just didn't do this correctly. So you can modify this if you want, and you can tweak and improve if you need to. But the other option, if you want to do the exercise yourself, to experiment, just go back to the 2D sketches, close it here with a nice transition, probably with a tangent arc, you know, like this, and do this yourself, and then roll back in 3D, and you see what's going on. So this was one example. The other one, speaking of roll-unroll, the same thing. Even if you have something which is not a 2D profile, you can still unroll it. Let's do exactly the same procedure. You just use this as a reference. You can preview. Okay. Now, even that this is not a how can I explain? You don't need to do this with 2D sketches. You can just do very quickly. I don't want to limit your time. 3D sketch is much more convenient for you to build your curves in a different world. I would say, you know, it's something like this, and probably you can do this, and depending on your application, what you try to achieve. Let me just define the other one. So now, because what I did in this case is I'm making a 3D sketch, and we need to put it back into the other world, which is the revolve, you know, here back to the original. If it's a 3D sketch, because it's a very complex shape, any arbitrary shape, you need to say, okay, I know that you are going to put this back in this world, but you need to approximate. So that's why you put a tolerance, in this case, probably 0.2. And then this curve will be rolled back into the 3D world, as you can see now. So we are not limited to roll back only 2D sketches, but also you can just do this for any arbitrary 3D sketch. We have some customer example, which I cannot show you, unfortunately, but this helped a lot to reconstruct turbine blades, areas that it's very difficult to access. So this can be a really powerful feature as well. So this was, from me, I'll just roll back the screen sharing to Victor. See if you can just share back the object, and then we can answer questions and see if someone has any more comments.
Yeah, I will show one more example of this usage of unroll. So can anyone guess what is this part?
I guess it's exhaust hose. Ah, no. Oh my God.
No, it's actually pump housing. So you can unroll even this if just limiting is a factor of your imagination. So basically, if you unroll this part, it's like two almost straight curves and several, like, for example, you need, I don't know, probably 6 of them to create more or less proper loft. So what you can do, you just roll back the same 3D curves, getting a rough representation of your pump.
Cool. Yeah. And I guess it's much easier to do it with this approach, because when you unroll, you just think as a straight lines, much easier and nicer to control.
Yeah, yes, exactly.
So,
In this case, the 3D curve has like 3 points only. Okay, 4 points right now. If you would like to draw such curve across the normal scan data here, you would need, I don't know, at least 20 points.
Yeah.
And in this case, for example, here you can see that this curve is like rolled back. It's nearly absolutely flat.
Yeah.
Well, flat as I created it here. But if you would be trying to achieve the same result by going around this scan data, most likely you would end up with something too straight, because typically we always have some floating around issues when we are creating this. So already here you can see that it's like here it's more or less straight, and there it's like curling already somewhere. So just a little bit more control on things. So just this was another example. And coming back to our today part. So yeah, we are back here. So if anyone have any questions or something.
Can you show how you make the unroll feature at the pump? I don't know how you make this. At the pump housing in the previous.
Okay. We can go back to pump housing. So basically it's pretty nearly same, but this part of mesh is cut apart already. Yeah, so this is another part. Initially it looked like that.
Mm-hmm.
So basically I fitted cylinder over this edge, I think, or in worst case you can create 2D sketch. You can create 2D sketch anywhere. And okay, let's just show it. Extracting primitives. You can say this is a circle. Back extrude. And initially you can use this extrude as a like cylinder reference for unrolling scan data. If I'm not wrong, we can try out. Data, unroll, pick, view. Yeah, you can use.
Okay. Okay.
yes, it's not only cylinder, as you demonstrate. This is a cylindrical face from any object, can be used. It just takes the radius. And while you're here, can you quickly make a cylinder? Just pick this face, Victor's.
Which face?
Not the flat one, the cylindrical.
Yeah.
Go to construct cylinder from cut. It's the last on the right. On the no.
Okay.
And now edit this cylinder and make it bigger. I mean, no. Bigger radius. Edit the cylinder.
The first one?
The actual
the
right click, edit. And now with this handle, just make it bigger.
Okay, this is nice.
So if you put it now. Try to unroll this mesh once with the from the cut model, once with this cylinder, so the people can see that this actually makes a totally different shape.
Okay, let's do that. So let's hide this. Unroll. First, we're using one. Okay. Secondary. Unroll. Pick this one. Okay.
So what you see here is that, you know, depending on the cylinder, the actual shape, the roll shape might be different. There is nothing wrong. It's just when you roll back, depending on which mesh you work, you need to roll back using the same,
okay.
same frame.
Mhm.
You know, this is the theory of the unrolling on the cylinder.
But why do you need two different sizes of cylinders? I think one dimension is good enough.
Yes, but sometimes what you see here is you try always to fit the cylinder where are the features, where you want to go to work after that, you know, in a way. It will still bring it back, but maybe you lose accuracy, or you see here your thinking is one of the holes are not exactly whole, the other one are smashed a little bit. If you put it Victor's view from Z direction, from top, you see here,
Yeah.
they are the same thing. You will, when you roll back, you get similar results, but one is kind of a smashed. So yeah, this is just an illustration of when you do this roll and roll stuff. Yeah.
Yeah, I just created two different lengths of these curves in different locations and rolled each one using different roll frame. Here we have both of them aligning.
Yes.
Okay. Mm.
Maybe it's like a scaling factor, right? Also, if you would use the exactly the diameter of the pump itself, then the enrolled scan data looks in the same ratio.
Exactly.
Yeah.
Yes, exactly. But
Factor is
it depends on which feature of this scan data you are looking. Because,
Yes,
for
yes.
example, first one was unrolled by like this edge, so probably representation like of this flat part here is better than here. So here we can see that our studs are like oval studs, and here we can see that they are round ones. And considering that larger diameter was pretty close to this flange looks way less distorted than this one.
Exactly.
So yeah, it basically depends on which part you want to work, and like probably to have like a more exact representation how it looks like unrolled in real life, just not to let yourself to be confused because like of shapes that you see here right now. So anyway, result at the end, as we see, is similar. If not similar, it's nearly same. But just it's like your comfort zone of seeing things and like receiving information from this visual representation of this unrolled scan data. That's the only difference. Otherwise, everything works the same.
All right.
As for the experiment, I don't know, probably what happens if we say create sketch. Okay, let's create it there. Let's take one stud. Okay. Let's roll it back. I'll sketch. This was second frame. Okay, so it appeared here. Okay, and let's create same sketch. These oval ones.
So the unroll feature is only for positioning the 2D sketch, not for extruding.
No, it's not for extrusion. It's I'm thinking that we may implement this in the future, but for now, that's why you need to. It's a good question, if we can roll back extruded body, then it will help even more in some cases.
Yeah, probably, but it depends on cases.
Yeah.
Now it's
Here
round.
we see,
Okay.
Nice and round.
You
More or
demonstrate mathematics, yes.
Cool.
Just an experiment. I had no idea if this will work properly or not. Of course, they are not like completely circular here, but
No.
same as the scan data is not actually circular here. So it's like
Yeah.
Basically you won't use this feature in this way. It's just like experiment to see the difference between like more distorted scan data or less distorted scan data representation, considering which diameter cylinder you are using here. So result is same. It's just more about experimenting this thing.
Okay. It's been an hour already. And it was I enjoyed a lot. I hope that you also learned from this session. If you,
Yes, of course.
If you have any questions, please ask. If not, we'll just stop for today and we will meet you on our Facebook. If you haven't joined still, you can find us on Facebook, or you can contact us at the support for any ideas what we need to do next time.
Yeah, as we talked in our previous in our previous online workshop. So if you have any ideas on parts, but maybe you are struggling about something, or just have different idea of parts that you would like to see reverse engineered here by us, just send us message over on Facebook group, or you can send directly to like support@quicksurface.com. So it's free for everyone. You can always ask something and get some answers.
Yeah. Okay, I will just stop the meeting in this case. Thank you, everyone.
Okay.
Have a
Thank
good-
you
very much. Yeah.
Bye-bye.
Bye.
Okay, bye.